Yeah. Okay, good evening. Today's session will be talking about wireless LANs, focusing mostly on the wireless LAN configurations. So today I have a very simple topology. Uh, right, topology on the screen. So I can see we have a server, a router, a layer 3 switch. Then we have a PC which is being used as the administrator, going to be used to access our wireless LAN controller. Then we have an access point, a lightweight access point, which is going to be controlled, monitored by the wireless controller. Then obviously we have the wireless host, a adjacent to connect to the wireless LAN that created by controller radio. Right, so maybe let me start by just a basic description of wireless controller and access point. Chi. So in a campus network, in a small network, we have access points. Access points, they're used basically to extend a wireless LAN. Yeah, I'm not Wi-Fi, if I can say. So access point, if you want to extend, you want more range on some access points so that you extend Wi-Fi yako. In an enterprise network, access points can be hundreds, can be a lot. Kana uri kumanager one or two access points is very easy. You can manually configure one at a time. But in an enterprise network, that becomes very difficult. You need another device to manage and to monitor all of them. So ndosathini knows wireless controller. Controller redu will sort of be the central device which manages all my access points edu. So in this simulation at Chaita, we're going to simulate using just one access point. It could be many in a very simple network edu. So we have a server. If theory serves us well, server RAID will be used as a radius server. So I think theory discussed something to do with AAA authentication and AAA authentication, authorization, and accounting. Radius server RAID will be used for that. Then admin PC will be used to access our wireless LAN controller. We're going to create our wireless LANs on our controller. Then via the K-POP protocol, all that information in the kuma access points. Then from access points, my wireless host here will be able to connect to the Wi-Fi, connect to the wireless LAN. Right. So a sort of prerequisites. What you need to know kana tasvika kuno kuma configurations of my wireless LAN, you need to know about my VLANs. You also need to know about my interVLANs. And the reason for this is when we are going to configure our wireless LANs, every wireless LAN ringe VLAN rayo, it is associated to its own VLAN. I think we did my advantages yeku-segment a network kuva nema-VLANs takatanga ne-subnetting layer 3. Ma-advantages anga aripo security, managing network becomes much easier, quality of service becomes much easier. It's the same thing here. But no creator my wireless LANs edu. Every wireless LAN is associated with a VLAN so that we separate my wireless LAN edu. It becomes very easy to scale, for example. Kana uri kuda kuedera another wireless LAN, it will not affect my existing wireless LANs because of anenge ari my separate VLANs. So, but you create my wireless LANs here per controller, every wireless LAN will be associated with its own VLAN. Starting from there, it means the layer 3 switch ready open up. True for create my VLANs so that ndo associate my wireless LANs on our controller. It also means for wireless router ready we need to configure inter-VLAN so that traffic between different VLANs should be able to communicate. Right. That said, I think let's quickly move my configurations edu packet tracer so that it is set up a topology adoshandisa. So for this one, I chose to use 1941 router. Let me see, we need a switch. Okay, we need a PC for admin. We also need a laptop. Pama switch, we need a layer 3 switch. We can use any switch. We also have a server, a chicha setup access point. Okay, lastly, access point. Which one should we use? Okay, let's use this controller. Then lastly, access point redo. Let's use this one. Right. Do simple network here. Do at Chashandisa. Let me make my connections. Okay. Why? Let me use copper straight. Gig 00. Okay. Two. Okay, three. Right. A simple network here is up. Right. And let's talk about topology. This is the addressing table. As you can see, addressing table paid per router number one. A tiny network 172.31.1.0/24, which is the network side going to save. Then you can see tiny sub interfaces like create .5 and .200. My sub interface they were created specifically because Tinema VLANs. So from two sub interfaces, it means we have two VLANs are configured per device rail. Tina VLAN 200, it was switch in IP address 192.168.200.100. Then we also have okay, the management IP address here, wireless LAN controller redo 192.168.200.254. Right. From the addressing table, one thing I have to highlight in Yama sub interfaces. The reason why Tinema sub interfaces, like I said, every wireless LAN is a creative of VLAN. Therefore, we need inter-VLAN routing per router redo. Therefore, that's why we have sub interfaces. Sub interfaces at now E.5. You see, we are going to create VLAN number 5, which will be used for our wireless LAN traffic. We're only going to create one wireless LAN for this exercise. If we to create more than one, probably we have a .10 again, which will be used for traffic in Ngedem wireless LAN 10. It associated to VLAN number 10. Right. We also have .200 Ziripapo. This one is associated with the management traffic. So when you talk of management traffic, it's traffic, for example, when admin Edu wants to manage the controller, when you want to connect to the controller, that is management traffic. It's not part of traffic iruva from a wireless LAN. So traffic here, there is a VLAN which is created specifically for that traffic only. Traffic here control between access point, the wireless LAN controller rate. That traffic also, it traffic management, joining it associated with VLAN, joining it associated with VLAN number 200. So two my VLANs that you creator here is VLAN 5, which is going to be for our wireless LAN. Then VLAN 200, which is associated with the management. Right. My configurations, let's start. So for my configurations, I will start with, let's start with server. Let's start with zvinhu zviri much easier. Let's start with the server redu. Toisa my IP address. And for our server, our IP address is 172.1.254. Let me confirm our server. Yes, 254, 255, 255.20. Our default gateway, send 231.1.1. Right. We are done with that one. Okay, server already done. Tender for admin PC. Admin PC yedu in IP address. It's static at this point. Kumberi, you see that sometimes wireless LAN controller with any capability go assign my IP addresses. We're going to discuss wireless LAN controller using its capabilities go assign my IP addresses, go assign only for my devices are under management. For example, admin PC, for example, access points S. So access points S and addresses dynamically in a controller is one of the functions of a wireless LAN controller. But my devices anenge ari kuzocommunicate anenge ane wireless LAN traffic. My PCs, my phones, all the devices that are connected to the Wi-Fi. My addresses, they will be assigned dynamically. At times, you can choose to use wireless LAN controller, but it my limited capabilities. So you see with my devices, my laptop, it will get its IP addresses from the router. So two different things. The addresses is over per wireless LAN controller, which by recommendation, anofana kunge ari ma addresses achaassign ma access points, ma addresses achaassign for example, PC iri kumanager the controller. Ma addresses wireless LAN puracho muchaona tichacreata parouter instead of pacontroller because my capabilities controller redu are very limited. So to start my configurations wireless LAN controller, we have a static IP address achiasa paadmin because hatisati tati configure controller racho, so we cannot get an IP address from the controller at this point. So admin yedu is 200 or 200, I think. Admin 200 or 200. Okay. 9268, 200, 200, 255. Right. Then our default gateway is 192.168.200.1. All right, we are done with that one. Then to end up, let us go per controller redu. Or let me start with router. My configurations epa router tichaisa 1. I think I'll need to write this down. My configurations epa router tichaisa 1. Okay. Right. Obviously, we need to activate interface rene 172.31.1.1. Interface rene server, side rene server. Then the other interface rene my sub interfaces, a interVLAN. So we need to configure my sub interfaces on the other one. Right. My sub interface is tnet.5, tnet.200. So ndoma configuration is a router. Let me see. So it kind of router, let's start with gig 00. Side rene server. Giga Ethernet 00, side rene server. Okay. IP address. Okay. IP address 172.1.1.1. Okay, IP address the hapo. We activate the link. Link redo hapo. Then topinda 01.5. topinda sub interface VLAN number 5 toisa let me confirm. Right. To check let me see my configurations inter VLAN. The reason why I'm doing this is to emphasize the point yekuti munhu anofanira ane configurations ake achiziva kuti if I want to configure inter VLAN, I have encapsulation.1q associating the VLAN ID to the interface. Then I have native, and basically that's it. This IP address. Okay, so my configurations, sub interface, I can start with encapsulation.1q VLAN ID is VLAN 5. Okay, this IP address is 17192.168.5.1. Let me confirm. I think it is that address 255.5.0. Right. Then I think basically that's it. Tupinda imwe sub interface .200 and this encapsulation .1q 200 this IP address is 200.1. Right, that's it. Then tupinda the parent interface so that I can activate the link. No shot. I think my sub interface is Apple. I just confirm with show IP interface brief. Right, 00 yangu is up. .5.200 is they're up with my IP addresses out. So for the router, I think we're good. Then to end up okay. Then to end up layer 3 switch. My configurations are set up a layer 3 switch. And shall create my VLANs. Because it's in a VLAN 5, the VLAN 200. So for layer 3 switch, let us configure VLAN 5 and then VLAN 200. Enable VLAN 5. And we're going to name VLAN 5 wireless LAN 5. So it's traffic for wireless LAN 5. Then we have VLAN 200. Name it's management. Let's call management. Let's call that VLAN management. Right. Let's associate my VLANs add with my ports. So if theory my VLANs yakapinda port first 02 it will be access associated to VLAN 200. Right? Port 01, it will be a trunk. Port 04, it will be a trunk. Then port first 03, it will be a trunk as well. Right. Why they are trunks 3 and 4? Port 3, it will be a trunk because this access point is not going to create two wireless LAN panel, which means two VLANs. Access point ndo rinenge riri kubroadcasta two wireless LAN iwayo. Zvino kuti traffic ichasvika pa-access point it will be from two VLANs. Therefore, this one automatically becomes a trunk. Then this one also becomes a trunk because traffic inobva ku-access point, depending nemode inoshandiswa necommunication yedu, mostly traffic iyoyo inotanga enda kucontroller first, then controller ndoyozoendesa to the final destination. So it means port number 4 here, it also becomes a trunk. Right, so knowledge you can understand VLANs, it also becomes very important wasvika kunoko. So VLANs atiri kuita is just the foundation yezvinhu zviri kutera. Right, let's associate maports edu starting with port first 2. First 2. This one is going to be an access port. Switch port mode access. Access, right? Associating with VLAN 200, switch port access, VLAN 200. All right. Port ready, Aurora, right? Then we have port number 1, port number 3, and port number 4, matrunk ese. Right. It's very important. Now, knowledge yekuziva inonzi native VLAN. It's very important to understand kuziva knowledge native VLAN at this point. If tikaisupport number 4 iri as a trunk, traffic iri kubva wireless LAN controller redu for management purposes inenge iri associated neVLAN chi. It's not associated to any VLAN. It means it's untagged. Therefore, there is need yekuassociate all untagged traffic to a native VLAN. So native VLAN yedu tichaita 200 so that admin yedu yataisa VLAN 200 can be able to communicate wireless LAN controller radio. So our native VLAN in this case is going to be 200. Ukasaisa native VLAN, you will not be able to have communication between, for example, admin PC and wireless LAN controller rako. So let's see interface. We have 1, 3, and 4. So let's start with 3. Right. Switch port mode, trunk. Auto cannot be configured as a trunk mode. Okay, an interface whose trunk encapsulation is auto cannot be configured as a trunk mode. Okay. Switch port. Let me see. Let me deactivate that auto negotiate. Switch port negotiate. Switch port negotiate. Okay. Switch port negotiate. Conflict between negotiate and dynamic status. Hibana. Switch port mode trunk native VLAN negotiate. Mode access. Mode trunk. Switch port mode trunk. Renable DTP. Disable DTP. Run button. Let me see port remove mode EP. Right, show VLAN. All right. Port number 3, default port. Okay. Show interface trunk. I'm gonna try and get a config going. Config terminal. Interface fast 04. All right. Switch port. Mode trunk. Command rejected again. An interface whose trunk encapsulation is auto cannot be configured as trunk mode. Why is it rejecting this one? Just a minute. Waziyenzira yeparuware. Mune vanhu here muno? Many people do we have? 5. Right. Command inoreva iri. An interface whose trunk port encapsulation is auto cannot be configured as a trunk. How do we remove that? Switch port mode, encapsulation, negotiation. If both devices agree on the same, therefore the interface is auto, can successfully transition. Now negotiate. I'm thinking the right command to remove that one is now negotiate. Not so sure why it's not allowing me to do that. Let's see, first one. Running out of time. Terminal. Interface first. 01. Switchboard mode. This. access later. Switch mode. Trunk. All right. Later. All right. Trunk writer port number one. So port number one trunk ball. Then port number three. Port number three. Take note of your rejection here and find how we should get ways around it. Ndandifunda kuti ndanegotiate inoshanda, but ina switch point access. So ways around it. Tatanga sub access, then put it also trunk. Okay, operator. Then port number three, trunk, port number four. Another trunk as well. The beauty the network yako from number one instead of going via packet tracer labs is because unosangana nezinto zvakaita seizvi, and you have to find ways around it. Normally, switchboard mode non-negotiate should work. Do not this here that the encapsulation is auto. Not so sure why it's shouldn't in this case, but I don't have time to investigate. So let's go. All right. So esendamaisa matrunk akufanira kuiswa native as well. Switchboard trunk native WLAN 200. WLAN 200. Okay. Then port number three. Native as well. Then the port number one. Native at 200 as well. Right, my configurations, the trunking angle is done. Then let's go per controller. Let's go per controller and see my configurations anofanira kuita. Right, tikaenda pa controller yedu, one of the configurations that we need to have is to change management IP address. So controller yedu rine IP address. Admin kana arida kuita access to the GUI recontroller yedu, it will need to know the IP address recontroller. And panapa, you can see controller redu, the network in a controller redu, 192.168.1.1, 255.255.255.240 is different from the network yataisa admin yedu. Yataisa management devices edu, for example. Management devices edu ese tamaisa 192.168.200. Do network yataisa management devices edu. So it means controller redu rinofanira change IP address so that rive IP address iri network management devices edu. So we're going to change controller redu. I think from topology yedu, I think I can change as well. Let me see and confirm. I think ndakaipiwa redu. Right, there it is. So controller redu management IP is 192.168.200.254. It's the IP address. This needs to change. Because I change, you won't be able to access that controller. 0 or gateway 0 200.1. Right, I think we're done. Now, let's test for connectivity. Tunaona network iri functional ere. I'll go to my admin PC. Let's test the connectivity with the server. Let's start there. Just to see connectivity, is everything okay? So I ping 172.31.1 dot, is it 254? Ikaramba communicate ndo panotangira networking ipapo, like there. Okay, that one no communication. Let's see if we can communicate with let's ping our default gateway 192.168.200.1. No communication with our default gateway. Let's see if we can communicate with our wireless LAN controller. Ping 192.168.200.254. Okay, so communication with our wireless controller is there, but communication with our default gateway and our server is not there. I think I know why. There's a native VLAN. There's a native VLAN per switch port 40. Pana port 10. There's a native VLAN, but there's a native VLAN this other end. I'm hoping that's the problem. 3 minutes. Enable config terminal interface gig 00.01 01.200 200. All right, native VLAN. Is it encapsulation dot 1Q 200 native? Okay, that's the command. Right. To pin that, the other interface. If there's a native configuration mode. Okay. Okay, done. I think we're done with this one. All right. So let me confirm again if we can get access to, all right, prop native ndio ngati kutsvaga, then connection to the server. Hebana. 1 minute. All right, connection to the server. All right, communication yapo. All right, so just to round up, I have less than 1 minute. Just to round up, topology edu yapo, my configurations edu, VLAN apo. Most importantly, native VLAN apo. Connectivity between my devices ese yapo. So chasara kuchienda kuno create my wireless LANs edu pa wireless LAN controller, then connect our laptop to the wireless LAN at Negata create. Any questions so far? 30 seconds for any questions. Unaona ngani? Baloi na Tanya. Any questions? No.
Sema
Yeah? Yeah. For me, random questions are go, you're not even audible. So let's just continue personal questions.
sawa.
All right. If you want to join in, do tanga session after this one so that I can finish up.